Hello and welcome back to SVSU's online tutoring. My name is Joel and today we will be looking at section 7.6 complex numbers, and the topic is actually complex numbers. So what I've done is that I've taken two little blurbs here so that way we can take a look at them and read them together. So reading the definition of a complex number is that if that a and b are real numbers, the number a plus bi is a complex number, and it is said to be written in standard form. So if b is equal to 0, the number a plus bi is just equal to a, where a is a real number. And so if b is not equal to 0, the number a plus bi is called an imaginary number. A number of the form bi, where bi is not equal to 0, is called a pure imaginary number. Okay, so what that means is that what this definition is telling us is that a number cannot be both real and imaginary. Okay, so for instance, numbers like 0, 1, 1.5, pi, square root of 2. These are all real, okay? These are all real. But numbers like negative 4i, 2 plus 5i, or even negative 1 plus I. These are all imaginary, okay? Imaginary. So what we want to do then is look at this little diagram here, and that if we have numbers that are both real and imaginary, together they make up what's called a complex number. Okay. So if we wanted to find what the inequality or what the equality of two complex numbers is, so if we have for instance square root of 16 plus the square root of negative 25, we can find out what that is. So the square root of 16 is fairly straightforward. That's just 4. And then using our general definition for the square root of negative numbers, we have the square root of negative 1 times 25, which is, let's see, so square root of 25i. And so we have 4 plus, the square root of 25 is 5, so we have 4 plus 5i. And that would be our solution. Let's see. And this right here is also our standard form for complex numbers, okay? And then if we wanted to find out what, if we were dealing with some variables, so if we were looking at, say, if we wanted to find solutions for x and y in this equation, so if we had 3x minus the square root of negative 36 is equal to 9 plus 6yi, what would that be? So what we have to do is that we have to set the real parts equal to each other, and we have to set the imaginary parts equal to each other. So I have this 3x and 9, those are my real parts, and then my imaginary parts will be the square root of negative 36 and this 6yi, okay? So starting with my real first, I have 3x is equal to 9, and so to solve for x I just divide both sides by 3, and I get x is equal to 3. And then for my imaginary imaginary, I have that negative square root of negative 36, which is equal to 6yi. And so I want to simplify my radical first. So using our definition, 6yi. So I have the negative square root 36i is equal to 6yi. And the square root of 36 is 6, so I have negative 6i, which is equal to i. And then, since I'm solving for y, I can divide both sides by 6i, okay? And what happens is that both of these cancel, and then I'm left with y being equal to negative 1. So my solution for this equation is x equal to 3 and y equal to negative 1. Okay, that wraps it up for the introduction of complex numbers. Next time we'll be looking at operations with complex numbers. Okay, see you next time.